Welcome to the 6th module of this training. Through the course of this module, we'll learn how to write undetectable applications and make the program invisible for antivirus software. As our first move, let's consider which techniques are used by antivirus software to detect threats. First of all, antivirus programs make use of signatures, and that's our subject in this part of the module. They also use heuristics, which we'll thoroughly discuss in the next part. Finally, antivirus programs also use emulation, and I'll tell you more about that in the third part of this module. Use of signatures is definitely the simplest way of detecting malicious software used by antivirus programs. They are simply byte strings which are characteristic for the given program. We get them when updating our antivirus. But how do we seek signatures? For this task, we use the dsplit program to split our application into parts, each larger than the previous one. Thanks to this, we'll be able to figure out from which byte we've been detected. The moment we find the signature and specify its location, we have to determine the section in which it's present. If the signature is present in the code section, we'll edit it using Ollie Debugger. And if in the data section, we'll use Hexplorer. Let's see how to search for signatures in practice. Here we have the ReseHacker program. It's a popular resource editor. It's not dangerous for us, but was encoded or packed using a packer recognized by antivirus software as potentially dangerous. We won't use programs from the previous parts because they weren't added to the antivirus databases and won't activate the alarm. Now let's scan the ReseHacker program using the Icarus antivirus. We can see that it detected a threat. Additionally, we'll send our program to the VirusTotal online service, which will scan the application using a few dozen scanners. The file is loaded to the server. Scanning is currently in progress. As we can see, the thread was detected by the programs Emisoft and Icarus. The analysis is still not over, but as for now, let's deal with modifying the program so that it's undetectable by the Icarus. Let's see how it should be done. We use the dsplit program to divide the file into parts. It takes the following parameters: the start of the section, the end of the section, the value by which the files will be increased, and the name. Each part will be larger than the previous one by 100,000 bytes. We can see that the program created the relevant files. We got as many as 13 parts. Let's scan them independently. All 13 files were detected, so the signature has to be present before the byte number 100,000. We remove the remaining files and split our program from 0 to 100,000 bytes, but this time each 10,000 bytes. Let's scan it again. We can see that the smallest detected file is the file that ends with 90,000. So the signature that activates the antivirus software is present somewhere between byte number 80,000 and 90,000. We write 80,000, 90,000, and this time increase each 1,000 bytes. Let's scan it again. As we can see, the signature is present somewhere before byte number 86,000. If so, we remove the files and this time we split the section between 85,000 and 86,000 to be separated each 100 bytes. This time all 10 files were detected, so the signature is present somewhere before byte number 85,100. Now we can set the section from 84,900 to 86,000 with the interval of 10 bytes. Unfortunately, we've set a bit too much. Let's remove these parts and set 84,900 to 86,000, each 100 bytes. Again, the youngest file is 85,100, so the signature is between the byte 84,900 and 85,100. This tells us a lot more. Now we'll set this section and set the interval to 10 bytes. The result is 85,090, so the signature is present somewhere before this byte. Now we set the difference to 1 byte. We see that 12 files were detected. We figured out the relevant address. It's the byte number 85,089. The signature was detected under this address. We remove all files apart from the one with the address of our signature and use the LordPE program to find the place specified by the address. But first, we use a calculator to convert the address of our signature to the hexadecimal system. It's 14C61. Now let's use the FLC option from LordPE to find the right place. We enter our address in the offset field. As we can see, it's a data section. It's not a code, so we'll use Hexplorer to edit it. Now we copy this value and drag the RHEXE file to Hexplorer. We use the option Go to Address and enter 14C61 in the offset field. It seems that it points to a character string, so we can freely remove it from the file. We select the area and choose Reset Selection. We see that everything was reset. We save the new program as RH2EXE. Now we can scan it using a local antivirus software. As we can see, no infection was found. Let's send it to the VirusTotal website to check whether nothing gets detected. The file is loaded to the server. Let's wait for the scanning results. By the way, we can see that MSsoft stopped detecting the virus. Let's wait for the analysis to complete. Meanwhile, we'll check whether the program still works after our modification. We start the new application version, and as we can see, the program still works well after the introduced modification. The analysis is over, and the result is stunning. None of the 42 antivirus programs considered our program a threat. To summarize this part of the module, we've learned how to relatively quickly find the bytes which belong to the signature activating the antivirus alarm, and also how to modify the program once it's detected. In the next parts of this module, we'll learn how to deal with other, definitely much more advanced, detection methods. The already mentioned heuristics and emulation. Thanks for your attention, and see you in the next part.